Okay, let's get this one on the road. First of all, just like to thank you all very much for coming to this session on the last morning of TechEd. I hope you've had an enjoyable show. Certainly, it's been good from my point of view. And if you were following the football, I hope it all went in your particular favour, and commiserations to those for whom it didn't work out. But don't worry, England were out of it ages ago. So, okay, so a little bit about me first. I'm an MVP. I've been an MVP in Microsoft Mobility for like 10 years now. So been through all the different generations of Microsoft mobile solutions. Currently focusing on Windows Phone and moving into Windows 8, which is all very interesting. Windows 8, the whole way that apps work has a lot that's been borrowed from Windows Phone, a lot of similarities there. So if you're also thinking of making that move, you'll probably have an enjoyable time of it. That's my email. I encourage you, please, to send me any messages of abuse or support, and I'm always ready to help anyone. My blog is on there. All the code for this session, there will be a post up on my blog straight afterwards with the link. I would have done it before, but I couldn't get the actual URL to figure out how to get it out of the current SkyDrive client I'm using, so I shall fix that straight after the session. And there's my Twitter feed as well. Now, I just want to position this talk very carefully. So you are obviously, I hope you've done a bit of Windows Phone dev. If you haven't, it doesn't matter. Maybe you've done dev on other Microsoft platforms. But really, this talk it's kind of a reflection of a journey that I've been on, because like most people, I kind of started with just the code behind model and creating apps using that. And it's kind of the way that Visual Studio templates kind of encourage you to do it. And a lot of the samples and step-by-step tutorials lead you down that path. And that's fine. It takes you so far. But you very quickly get into a place with even a moderately complex app that things start you start losing control. So, you know, this whole idea of MVVM and good architecture, this is what this talk is about. The clue is in the step-by-step sort of thing. The unit testing, yeah, it's about MVVM and unit testing. Unit testing is one of the wins that comes out of MVVM, but really, good architecture is just a win on its own. So even if you don't go as far as writing tests, but I will cover that in some detail at the end of this talk. But just the benefits of the good architecture are worth going for anyway. So I will be talking about how to make Windows Phone projects testable and how to go about it. So this session has been given a 400 because by the strict definition of 400, that's what it is. There's kind of loads of architecture stuff and high ideas and that sort of thing. But yeah, the clue is in the name of the step-by-step. What I'm trying to do here is make it easily understandable how you go from a code behind model and a couple of little steps in your thinking to get to a place where you've got something that is better architected, will stand you in better stead for the future. So that's where I'm kind of trying to go with this talk. So this is the agenda for it. First of all, just a quick, what is unit testing, how to build software that actually prevents you from testing. And then what we'll do is we'll take an example of one that is hard to test, and then we'll start modifying it, fixing it step by step. So first of all, I'm going to talk about separation of concerns, which is just really about good object-oriented design, really. But specifically in MVVM, it's about separating our presentation layer away from our business logic. And to do that, we have to move away from the code behind model. Then how to, once we've kind of refactored our solution into nice discrete objects, there's a few other steps we need to do to actually make it easy to test them. You end up with objects that have got dependencies on each other. So I'm going to look at, very briefly, dependency injection and how we can use that quite easily in our apps that allows us to end up with things that we can easily test. And finally, I'm going to actually run you through creating a unit test project, creating a unit test, and running some against a Windows Phone project. Technique, all this stuff is going to be Windows Phone 7.5, but the techniques I'm showing you will be just as applicable when we start developing for Phone 8. So, starting with that, unit testing. Oh, I encourage you, shout out if you've got any questions as we go along. We don't have to wait till the end, so please interact if you feel so inclined. So, if we want to get something that's testable, I mean, what are we trying to do here? So the idea is that we end up with a suite of code that we can run over and over against our application. And it means that as we develop that app and we add new features and that sort of thing, we can just carry on running that test to make sure we haven't inadvertently broken anything while we've been making our changes. And it's kind of easy to say what it's not about. We're definitely not about integration testing, although that's a crucial phase for you as well. It's about taking those little discrete bits in the middle of the project and testing each of them individually, writing a series of tests that actually prove that object A does what it says on the tin. This is what it's all about. And the kind of thinking behind this is if each of the individual little classes in your app are tested and have proven, and you've written tests that prove that they actually work, obviously if you plug them all together, then you've got a much better chance of the whole application working. You still need to do your integration testing, your end-to-end testing, and your user experience testing. That's not what we're talking about. But it gets you to a much better place in a lot of ways. And these unit tests, of course, are very important assets. You know, if you do this properly, you could easily end up with as much test code as your actual primary application code, the actual app that you're shipping. So, you know, you want to think about attaching a load of importance to this because there's loads of great benefits. You're investing in your product for the long term. If you've got a properly tested project, you can add new functionality and do new versions and roll them out more easily because you can do those fixes and test that you haven't done this thing where you change something over here and then this weird side effect that you hadn't anticipated breaks something over here. This is what we're kind of trying to achieve. And if you do this properly, obviously this leads on to the idea of test-driven development, which I'm not going to talk about. But just the principle behind test-driven development is that if you're building your application using the right patterns, you want to add a new bit of functionality, well, what you would do is you write the test first. Then you run the test, which of course it would fail because you haven't actually written the bit of the solution that's going to implement that bit of functionality. So then you actually implement the functionality, run the test again, and if you've got it right, it will pass. So this is the idea behind test-driven development. You write the test first, then you actually implement it. But that's kind of, you know, another step down the road, which I'm not going to go into in any great detail. Now, I'm sure you've all seen a version of this graph a number of times in your career, the kind of cost of bug detection. So this is another sort of illustration of the value of good testing. If you think of the cost of a bug at the requirement stage, well, of course, it's not a bug then because you're defining what your application wants to do. But, you know, you're sort of tossing ideas around. But if we give a nominal cost of 1 to something that you consider and then throw out at that stage, but then you've made a decision on your feature set, and then you get into the design phase, and then, you know, you start considering your design. If you pick up on a flaw then, okay, the relative cost might be sort of 5 compared to right at the beginning. Then when you get into coding it, so you're actually coding up this thing, then if you uncover a bug, well, you know, we get into sort of 10 times the cost. Now, by the time you shipped it out to your test team and they're doing their final test and user acceptance testing, they come across a bug there, then the whole impact of that bug detection later in the cycle, it all ripples through everything. You have to go back and change more stuff. You might even have to go back to your original design and change something. So the cost is just escalating all the time. The later in the cycle you find it. So if you've got good testing built into your coding phase, you know, you can head off a lot of these expensive things. And of course, if you ship it with a bug, well, that could damage your reputation, could be pretty serious. So that's clearly 150. And we can kind of superimpose a customer satisfaction graph on that. Now, okay, at the requirement stage, they probably don't even know you're building this app, and then maybe you might do a press release and say, oh, you know, we're about to release our app, so the customer expectation is kind of going up just before release. And then when you release this absolute dog of an application to market, and the people try and use it, and they slam it in marketplace, well, then that's serious damage to your reputation. So that's obviously something we want to avoid. So what I'm using as an example is a project that you might well know, which is there's a sample on AppHub which you can run through, which is this fuel tracker application. Have any of you run through that tutorial? None. Okay. Well, yeah, one person there. It's kind of it's a good step-by-step thing that's in the MSDN documentation, and it walks you through the process of building an application. And this is the app, and let's just run it up. It's a very simple little application. So this is the home page, and we haven't got a car registered here. So the first thing you do is we have to go onto the car details, and we're going to enter a car name, so Jaguar, whatever, and we've got to put an initial mileage on it. We can choose a picture for our car. So here we go, bicycle wheel, that'll do. And then we save it. So there's our car. And then we can start registering fill-ups. And it just measures the fuel efficiency. So let's say our first fill-up we do at 450. And this is a clearly US app. So US gallons, I have no idea. So let's make that 16. Price, let's guess, I don't know, 360. And then we can save that. So that's our fill-up. And actually, we're only getting 12.5 miles per gallon. That's probably about right for an old Jag, actually. Yeah, and then you can just carry on doing more fill-ups, and you can look at the history. So this is the app, and that's it. It's fairly simple. Now, so there's lots of interesting functionality there. I mean, but if you can kind of imagine this as being a real app, then maybe we want to. What's the sort of thing we're going to want to do to test it? So we might want to test that when we enter some stuff in here, when we hit the save button, it actually saves it away to our model. That might be a good test to do, and that's something we can have in our test suite and run over and over again. So let's think about how we might do that. So the logic for the car details page, this is obviously the UI for it here, and we've got our app bar down there. So presumably there'll be a click event, something on the app bar somewhere down here. Yeah, save button, so we can navigate to the event handler. So here's the logic. So you can see how this is a typical code behind sort of app. Behind the XAML page, we've got all our logic and our validation is all built into the same class. Here it is, all the stuff here. And here's the stuff that we want to. This is where it actually saves in the car data store.car. It actually transfers all the data across. So let's think about how would we want to sort of test that? Well, let's have a go. I've actually already added to this a unit test project. I'll walk through how you do that later on in this talk. So here's our test project, fuel tracker tests. And down in the unit test thing, so you create unit tests using the same attributes that you might be used to with the standard Visual Studio testing. So we've got a test class. There's a test initialize method. Here's a test method. So let's think, OK, so how would we test that save button? Well, we'd obviously need to new up that class. So we'd new up a car details page class instance. We need to have a car object. And actually, back in that page, it actually sets the data context. So the binding context for that page points at this car object. So we can kind of simulate that here. We can set the name of that car object. And then, well, we want to try and execute the logic in the save button. And actually, there's no real way of doing that. So we can kind of car DP, and there's all the methods on the page. We can't actually call the save event handler. There's techniques we could use to get around that. But immediately we're into difficulties with the way that a standard app is executed. And let's assume that the test made sense. If I actually try and run this thing, we immediately see the problem of having our presentation layer. This is the standard UI you get for the Silverlight unit test runner. And immediately what we get is an exception when we try and run a test. And the exception is a XAML parse exception occurred. So this straight away illustrates the problem of having our presentation, our XAML bit, mixed up with the logic we're trying to test. Because what it's trying to do is parse the XAML on that page. This is a UI class. So immediately we're running into difficulties with a sort of a code behind structured application. So what we're going to do is fix this problem. So that was a not testable thing. So the way the way that we're going to do that is this idea of separation of concerns. I love this phrase, separation of concerns. What it actually means is good objects. It means about having discrete objects that have a distinct purpose, not one of these big. I once had a client come in to me. They rang me up and said, I could do with some consultancy. So it was a Windows Forms app. So they said, I could do with some consultancy. I'm having a bit of problem. I've been asked to add some functionality, and things are going wrong, and I really could do with some a bit of expert assistance. So I said, yeah, fine, okay, come visit me. So this guy turned up with his project, and he opened it up in Visual Studio, and he showed me this thing. And this application, it had one form1.vb, and it had 60,000 lines of code in one class. So I said, okay, let's start with object-oriented design then, because we've got a serious amount of work here to sort this problem out. So obviously that's a big extreme, so that's kind of excessive. But what we're going to do is kind of start looking at MVVM. So this is this pattern that's very similar to MVC or MVP, which you may be more familiar with, but it's just another flavor of that. And what it's all about is making sure that the presentation bit of your app is separate from the logic bit of your app. So you end up with different classes, and the presentation in the context of a phone app is just your XAML pages. And the code behind should only be about the presentation, and by that I mean showing stuff to your user and maybe accepting a bit of input from your user. But that's it. So it's just about the presentation side of things. And they should talk to a set of classes in the middle called your business logic, which is the VM bit of it, the view model classes. So this is where your view model classes are responsible for exposing the data that the view should show, and for sort of doing validation and any business logic that is a result of whatever your app is doing. So this is where your logic sits, but there shouldn't be there's no presentation, there's no UI associated with that middle layer. And then the M bit of it is your model, which is just your persistent data. And that's kind of a flexible concept, what a model is. It may just be flat files stored in isolated storage, or it could be in a database, or it could even be on the cloud or something. So, but essentially, it's your permanent data for your app. And one of the key rules here is that the view connects to your view model. It's a consumer of what the view model exposes. But your view model should have no idea that anybody is doing anything with the data that it exposes. Your view model exposes data. It has public properties on it, so people can kind of read those properties, and it has events that fire as well. But it doesn't have any idea of it's completely ignorant of anybody who might be using the stuff that it publishes. So you don't have any logical. There's no way for your view model to sort of say, oh, view textbox1.text, set the text property to hello world. There's no way for it to do that. It doesn't have any conception of there being a view or a text box. So that's one key rule with this sort of thing. And this, of course, because your business logic doesn't have any UI in it, immediately we get rid of that XAML parse exception, because there is no XAML. It doesn't have any presentation. It's just logic. It's just stuff that it's data in, data out, manipulate, do a bit of stuff, This makes it testable, so that's really good. So this is the goal we're trying to get to. So in my step-by-step, the first step with any phone app is to use data binding. So a nice simple step to get started. So this is the way that the view can link to properties on the view model and can show it. So instead of obviously having logic that is explicitly setting properties on of control, so you should never see a statement like this, textbox1.text equals some string, in a properly MVVM architected application. Instead of that, we use data binding. So with data binding, I'm sure you're all familiar with the idea of data binding. In this one, your UI controls will automatically get their values from the underlying view model class to which they are bound. And also, if the user kind of selects a radio button or types into a text box, that will automatically or can automatically get sent back and update the corresponding, the bound property of our view model. Let's put that into something a bit simpler. So data binding in XAML, like I said, I'm sure you're familiar with this. We have a text block control here, and there we have the text property. Instead of being set to a literal string, what we've got in the curly brackets there is a binding statement. So what that statement is saying that my text block content text is going to get the value to show from some property of a bound class that's got a name line 3. What that statement doesn't do is say what that bound class is, what that view model class is. It just says when I'm bound to something, get the value from line 3 property. So you actually define the data source by setting the data context property, which could be set on the text block, but in actual fact it's more usually set like on the page or perhaps on a grid or something. You can actually, this data context property is a property on UI element, which is right down the bottom of the inheritance tree. So you can set it anywhere, but normally for kind of good organization, we probably would set it on the page if we can. And there's an item source property which kind of does a similar thing for lists, but there you're binding to a collection of objects rather than a discrete object. The mode's important here. So the default mode is one way on data binding statements. So let's go through them. One time means that when the page is first rendered, when the binding statements are first evaluated, the UI control will go off and pull the value out of the VM just the one time. And then thereafter, if any logic and background logic changes the value of that property, it doesn't get reflected in the UI. So it's just a one-time, get it, and then forget it. One way means it will obviously do the same. It will pull the value out of the property on the VM, but thereafter, if anything changes the value of that property, the UI will automatically update in synchronicity with it. And two ways just for UI controls that accept input. So if you've got a text box where a user types in, then two-way data binding means that not only will it show the value from the VM on initial rendering, but if the user interacts, that change will get sent back to the underlying VM as well. So this is how, text entry, for example, will get sent back. And the magic that makes all that work is actually not magic at all. It's very simple. So in your view model, you just have to implement this magic interface iNotify property changed, which basically means on a setter, whenever the value in the view model changes, we fire this property, the property changed event, and you just pass the name of the property that is being changed. And the subscriber to this event is the Silverlight runtime, the UI manager. So it's looking for these events being fired and updating UI controls that are bound to the property that we've just had the notification that it has changed. Now, while I was talking, I had my emulator crash on me, so let's hopefully we should be in good shape. Now this this fuel tracker, the one that they've got, does actually implement data binding. So we've got our car details page here. There's the UI, and we can see here we've got text. Here's the text binding to the name of the car, and then here's the initial odometer. So we've got the text property binding to the initial odometer reading of our car, and so on and so forth. The actual car object itself is up here, and there's the name property, and it implements all this iNotify property change. So we've got decent data binding going on in here. There's the picture and that sort of thing. So it's all right. We're kind of doing all right, but this doesn't implement proper MVVM. There's no view models in here. You've just got the views that are linked directly to our model in this kind of simple code behind model. So I've actually got another sample that kind of is a pure example. Have any of you seen the Jumpstart videos? So I couldn't do a presentation without bringing my esteemed colleague Rob Miles into it in some way. So this is a Rob Miles production. This application is called Damage Calc, which is it's actually just a currency converter actually, but it comes from Cockney rhyming slang that they have in London, as in, you know, whenever you're looking at the price of something, you say, what's the damage? What's the damage, Gov? You know, so it's damage calc. And like I said, so you can just, we can just put in a value, so $20, and we can figure out what the equivalent is in sterling, in UK pounds. And he wanted a special feature. Rob likes to buy cameras. He's very keen on photography, but yeah, his interest kind of really is about buying cameras rather than particularly taking photographs. And he keeps getting into trouble whenever he travels. So he wanted this feature added in as well, so that when it goes over a certain price, you get a little warning about this, saying, you know, think twice about this, Rob. Now, this little very simple app, if we look at the way it's implemented, here's our main page. Here's the logic here. So let's move that out of the way. Very nice and simple. You can see the UI. We've just got a text block and a text box. We're doing two-way data binding here to a property called $value. That's the kind of long form of a binding statement. You can say path equals, but essentially we're just binding against the $value property. And similarly, the one down there, we're binding to sterling value. That warning message, actually with visibility property, we're binding that to sterling value as well, but we're using a converter that basically looks at the, so we're binding against a number there, a currency value, but the converter class which we use in this looks at the value of that property and just sends back visibility collapsed or visibility visible according to whether it's below or above the warning threshold. So there's little data binding in here, and if you look at the code behind for this particular application, well, that's it. There is no code behind. We've got data context. All we do is set the data context to our damage view model, and our damage view model here's our view model class. Is implements iNotify property changed, of course. We've got a couple of constants there, and here's our private backing fields for the actual data storage, and here's our public property for the $value. So there's the getter, and in the setter, if the $value that's coming in has changed, then obviously we fire property changed for that event for $value, and then we also calculate, we call the setter of our sterling value as well, so that will actually cause that to fire property changed on that as well, and that's how the UI just updates automatically. So all the logic sits in this. So this is kind of the simplest possible expression of a nice VM. All the logic's in there, and we've got nice separation between our VM, where everything happens, and our view, which is just about showing it and accepting input. So that's a nice, simple example of that. All right, so data binding, that's the kind of simple implementation of that, where your VM is just simply publishing data. It's got properties, which is exposing data, and our view is binding to that, and it's getting its values, and it's sending values back. So that's the important first bit of that. But actually, because there's much more goes on in an app than that. What happens when a user clicks a button, or selects an item in a list, or something like that. So we actually want to be able to handle execute the business logic associated with one of those button clicks or interactions. We want to do that in our VM as well. And there's other subtle things as well. If our logic is sitting in our VM, then clearly at some point you're going to have some logic that says if A go to page over here and if B go to page over there. So we need to be able to control navigation from our VM as well. And that actually presents us with a slight little difficulty, because if you remember, our VMs don't have any conception of UI, and more precisely, they don't actually have a reference to any views. They can't actually get at the navigation service in order to call methods like go forward or go back. So we need to do a couple of these things. So step 2 in my step-by-step is to take our view models to another step and take them beyond just publishing data, and now we need to do this thing called commanding. So commanding is where we start to add into our view model not only publishing data, but also the ability to execute some logic when a user clicks a button or something like that. So instead of the traditional model of event handlers in our code behind doing everything, we need to load that into our view model, and we do that with this commanding technique. And it's quite easy to implement in the XAML. And this is a new feature we got in Windows Phone 7.1 SDK, because that's 7.0 was kind of based on Silverlight 3, and 7.1 we were up to Silverlight 4. And in Silverlight 4, we've actually got some limited support for commanding built into a few of the controls, specifically anything that inherits from button base. So hyperlink control buttons and relay and radio buttons, that kind of thing. They've all got this command property you can see there in that top little snippet. So you can actually bind the command property of a button to some property on the VM, and we'll look at that in the next slide, what that property looks like. Now, the command property on a button, it kind of is tied to the main event of a control, so the click event. But of course, controls have a whole load of different events, and also there's a whole bunch of other controls that aren't buttons that you also want to be able to handle the event firing over in your view model. So the other way of doing that is to use in Blend. You can have these invoke command action, these triggers. This is the other way of handling any event and handling it in your VM. So that's kind of what it looks like on the XAML side of things. What does it look like in our VM? Well, at this point, I have to just say I am talking about MVVM in general terms, but there are a bunch of frameworks that make this easier. So I'm actually using MVVM Lite myself, which is one that a fellow MVP develops, Laurent Bugnion, and it works for me. There are a bunch of others, and I've got a slide at the end with a list of all of them, so I'm not recommending one over another. What they do all tend to have, these frameworks, is a class called something like relay command. Now, this is the property in our VM that's going to actually handle, actually now becomes our click event handler, if you like. It's a type of relay command, but actually relay command is a type that's in MVVM Lite. It doesn't exist in the .NET Silverlight class libraries. And what does exist in the Silverlight class libraries is this interface called iCommand. So your property, the type of your property in your VM needs to implement iCommand. And all the frameworks have some object that kind of does this. And relay command has almost become the de facto standard name for this. So it's iCommand is the interface that's in the base class libraries. But here you see a simple example of a hello command. You don't have a setter on it, of course. It's simply something that the command implementation is something that your view will get and then execute. So that's what we're doing when we're binding to a command here. So this simple example, well, there's a lot of C# on there, but all that is basically saying is the implementation of the relay command is that line that says this.welcome title equals you change the title. So this simple commanding thing, when somebody presses the button, it just sets the welcome title property of this VM to you change the title. And if something was bound to that, that would be shown on the screen. So this is the pattern. You actually put your logic, your click event handlers and your event handler logic now sits inside the implementation of your relay command. So this is kind of commanding. The other one I mentioned was this idea of a navigation service. So VMs need to do navigation. So this navigation in Windows Phone is done through system.windows.navigation.navigation service, which is exposed by the navigation service of a phone application page class, and actually by the phone application frame. It actually sits in the phone application frame. And as you remember, view models can't call the view directly. So how do we actually get around this? Well, the typical answer for this, and if you go searching for this on the web, you'll see implementations of something called a navigation service. So that's what I use. Do the same on Windows 8. So we're abstracting all. This is also good object-oriented design. We're creating a special class called navigation service. Its job is to do navigation for us. Now that bottom line is important. It also allows us to mock the navigation service when we write unit tests. I don't want to go into that too much right now because I'll come on to that a little bit later in the talk. But the point is that if we have a well-factored object model in our application, we've got discrete classes that are doing things, this separation of concerns thing, we've got a navigation service over here and all the logic to do with navigation services in one place. It does give us the opportunity when we start writing unit tests to have a dummy version of that basically doesn't do anything. So this is how we can kind of remove the navigation service from the equation when we come to write our unit tests. Like I said, I'll show you how to do that, coming up. So in a diagram form, this is the problem. So we've got our view1.xaml page, and that is bound to view model 1. And of course, what we want, your user will interact with view 1 in some way, maybe click a button, maybe select some items or whatever. And inside the logic in view model 1, as a result of the user's action, view model 1 wants to cause the app to navigate to view 2. We want to show view 2 to the user. That's the next stage. And in order for view model 1 to do that, the view models need to have access to these navigate and go back methods that are on the navigation service, which, like I said, is built into the phone application frame, essentially. So how do we do that? Well, we can't actually do that directly. So there's a couple of techniques for that, but the best one really is this, actually externalize it into this navigation service, which can call those methods. And that's how the view models can use the services of this navigation service to do that. What does one look like? This is an implementation of simple navigation service. Basically, you just have the same methods you'd have on the normal navigation service. But as you can see, we can always get a reference to the phone application frame by calling the application.current static property, and then get its root visual property of that. So that gets a reference to our current application. So we can get a reference to our phone application frame, and that allows us to call the real navigate and go back and all the other methods on navigation service. But hang on to that fact. Really, the benefit here is we've externalized all that stuff into another class. And you want to think about that. Services, the concept of services, are good. And this again is, if your classes are getting too complicated and they're sort of doing too much stuff, you should always be thinking, oh, well, okay, I want to split that out and have a discrete class that's responsible for doing A, and this class over here is responsible for doing B, and don't mix things up. And we've all done it. You end up with a class that just grows and grows, and we're in a hurry, you just do a bit of location service stuff here. I'm going to put that in there as well. But it's actually a much better idea to always create a my location services class and have it all externalized and just all nicely compartmentalized. The benefits here, you're encapsulating your logic, so it's just good OO practice. You end up with nice reusable classes as well. But these things kind of typically have a lifetime that extends beyond pages. So you can just have a singleton that sits there and is exposing those services. And the typical example of that might be your data service that's responsible for getting stuff out of your persistent, out of your model and serving it to your view models. A data service is a good one. You might have a state service. I mentioned a location service. I always do this. I always think whenever I'm adding a new bit of functionality, I think, is this a service? Should I just create another class? It's always a good idea. The other real benefit of doing that is that, again, when we come to testing, we can mock them out of the picture, get rid of them, ignore them for the purposes of running our test, unless we specifically want to test the interaction of a view model with the data service, for example. So, MVVM and commanding. Now, this finished with that guy. This fuel tracker. What I've done is created a whole new version of Fuel Tracker. And this is called Fuel Tracker MVVM. So it's exactly the same app, does exactly the same thing, looks identical. It's got actually some additional features. I've actually got some data validation in there. There's a nice property you can put on your models, on your view models, called I notify data error info, but that's just, I was having fun, basically. So this new version, it works just the same. So let's say we've upgraded to a roles now. So we're doing well. Initial odometer on that was 4,000, and we can choose a picture for our Rolls Royce, which will probably look, well, I don't know, a bit like I don't know, a sunflower for some reason. And then we can save it, and it works just the same way, and looks the same, of course. But this has been architected under the covers. It's done as a pure MVVM implementation. And when we press these buttons and this sort of thing, we're actually using commanding. So let's have a look just very quickly at how that works. So car details page, the one where we enter our details of our one, is this guy here. I'll just point out a couple of things. Now I'm using here, there's the UI, it's just the same as before. We're still using data binding. There's the data binding stuff. But actually, one thing I want to point out here, I'm using, one of the problems when you start using MVVM is you'll find that the standard Silverlight application bar doesn't support data binding, which is not terribly helpful. So there's various solutions out there. I happen to use a tool set called Phone 7FX, which you can get from NuGet, and that has it has a wrapper around the standard app bar that enables you to do data binding. And actually, in this particular implementation, I am using the isEnabled property of this. I'm binding that to a property on my car object, is car object not empty. So that just enables or disables the delete button, basically, on whether we have got a car or haven't got a car. So that's enabled by using this Phone 7FX. Now, commanding, and on the slides I showed it as being, a command property, and in fact this particular button, of course, does have the command property. So I could bind it directly to my VM. In actual fact, just to prove there are no rules here, and this is one of those religious war issues. Some people get terribly upset about this, but as far as I'm concerned, doesn't bother me, because I actually have got an event handler in my view, but as long as it's still all right to put stuff in the code behind, as long as it's not doing any logic. If it's only to do with the presentation, it's not changing the way the app works, well, where's the problem here exactly? So you can get a bit kind of, okay, here we go. Yeah, so the comment there was about the application bar. Quite often you will actually build it in the code behind, because the particular problem, again, because you can't data bind the text, the actual the text of the buttons to localize it. So quite often, yeah, you build the application bar in your code behind. That's a good example, actually. It's still valid in this model, because you can actually still, in the view, as I'm showing here, you see what I've got here. The reason why I've done it in this specific example is that those of you who are phone developers will know there's another problem with the built-in Silverlight, the built-in phone application bar, is that when you click the button, they're not first-class Silverlight controls. So with data binding, by default, the binding, two-way data binding, only updates the VM when you lose focus on the control. So you get a common problem where people are typing into a text box, they then hit the save button, and what they've typed in doesn't get saved. It's like, what's going on? It's because that data binding statement hasn't been executed, because we haven't lost focus. The Silverlight runtime thinks you haven't lost focus from that text box. So this commit text box with focus method just fixes that problem. So just to show that. If text box with focus. So it gets the data binding expression and actually updates source. So that's why this is in here. Where's me? Go back. There we go. But then you see, in our view, we can get a reference to our data context, which is our car details view model. So the data context of this page is our view model. And then we can actually execute the save command directly from our code behind. So that's equivalent to just going command equals binding save command. So, I'm breaking the rules a little bit, but we haven't done anything logical here. It's just... so go to the definition of our save command, and here it is, the logic for our save command. So that's nice. Now all this stuff that was previously in the code behind is now in our view model. And you'll notice, so the logic is in here. I have kind of I did say that, view models don't do any UI. The exception to that is popping up a message box. So I've actually but I have externalized that in good service, like I was saying about services. Make sure everything that's kind of external, push it out to a service. So I've got this nice dialogue service which handles that for me. And this particular view model uses a dialog service, a data service, and a navigation service, which I'll show you how they're plugged in just a moment. So that's commanding, an important part of the equation as well. So where are we up to? In our step-by-step, we first of all just use data binding to connect our views to our view model. So that's one stage on the road to having nice separation of concerns. We've used commanding, so we're now handling a logic associated with button clicks and that sort of thing. That's moved off into our view model as well. And we've externalized some stuff like navigation service and dialog service and data service. We've got service classes that handle that for us. The view model will use the services of those classes. And we're looking pretty good, really. Now, so we're good in the sense that our view is concerned solely with the presentation, and our view model encapsulates all our business logic. But in terms of getting to something that's testable, we're still not quite there yet. The reason being because our view model is using, these services still present us with a little problem, and this is quite a subtle one. The problem is solved by a technique called dependency injection, which is one of those that you read about it, a dozen times, and when you finally get what it is they're going on about, you go, oh, that's really cool. So here I've tried to, and it's also a topic that you could easily spend a day talking about. So I've condensed one day of chat down into 2 slides here. So let's see if this works. So here's our main view model. And you can see that it's using the services of a data service. And in the constructor, so we're going to have to new up an instance of our data service at some point. And also down in our XYZ method, we're getting the car property from our data service down there. And we're also calling our navigation service. Now, we've actually coded that up using the traditional .NET singleton pattern. So navigation service.instance gets a reference to our single instance of our navigation service. But in either way, in both cases, main view model is tied to those service classes. It's tied very closely, actually. So this is creating a problem for us because it means that when we want to write a test for XYZ method, and we want to test the functionality that's in that method, we've got to worry not only about our main view model class, but we've got to worry about the state of our data service. So our test all of a sudden becomes complicated. We've got to, first of all, set up our data service, and then somehow we've also got to make sure that when navigation service instance.goBack happens, what effect's that going to have on our test as well? And the problem can get multiplied many, many times as well. So, we were only talking about one depth, one deep in our connection, our dependencies here. But of course, those classes could new up other classes as well. So all of a sudden, you end up finding this is difficult to test because of this string of dependencies. And in order to do a right test, you've got to write all this setup code, and it's just making life too difficult, and it's preventing us from doing good testing. So this is where dependency injection gives us a solution for this. So the idea with dependency injection is that you'll never new up anything in a class. You don't do it, ever. No. It's just a bad thing to do. You don't actually ever new up another instance of class or directly get a reference to a class. Instead, you get somebody else to inject that connection into your class for you. So what you actually do in practice, what this means is that on your constructor of your view model, you have some arguments on that which are the services that you want to use. They're passed in like that. And then we store a reference. And the other good thing that we do is that for each of those services, you represent that not as a concrete type, but as an interface. And in Visual Studio, in the refactoring tools, you can right-click on any class and say, create interface. So it will just look at the class. So you can easily create your data service class and then create an interface for it called iMyDataService or something. So in your view model now, it's representing the services that it wants to talk to as abstract types, interface types, and somebody else somewhere is going to, when we construct a view model, is going to find one of these I data services and one of these I navigation services, and he's going to plug it in at the appropriate time. And the thing that does that is something called a dependency injection container, which is a special component that's there just to do that job. So when we do this, the interesting thing is this. So we now want to write our test for XYZ method. The functionality in that method hasn't changed, still doing the same as it was on the previous slide. But the difference is that at runtime, of course, we're going to be using a real data service and a real navigation service. But when we want to come and test it, we can plug in mocks of that, which just are empty. They implement the same interface, but they don't have any functionality in it. So now we can have a mock navigation service that you can call its methods, but it doesn't do anything. So now we can actually start to do serious testing of our XYZ method. And this is the power that dependency injection gives us. Now, this is the one in MVVM Lite. What I'm going to do is actually just switch over to the demo machine and just explain how it works. So, let's have a look at car details page.xaml. Here's the XAML for it. You'll notice, okay, up the top, here we go, this bit here. Here we're setting in XAML, so we've often seen setting the data context in the code behind, but here we're actually doing it in XAML. It doesn't have to be here, it's just the way that the MVVM Lite templates create stuff. So here we're setting our data context. And the data context for this page is being bound to a property called car details on a static resource that's got a key of locator. So, okay, what's that? The locator is actually our dependency injection container. This is this magic component that does this stuff for you. So the locator is actually defined in app.xaml. Here it is. And it's a global resource for our application. There's a single instance of this thing called a view model locator, this class here. And that is stuck in our view models here, view model thing, and here's our view model locator. So this is the same as on the slide. Now, what a dependency injection container does, and this one that's used in MVVM Lite is the most brain-dead simple implementation of one of these things you could possibly think of. It's called simple IOC. IOC is inversion of control, which is the name of the pattern. It's the same thing. Dependency injection and IOC is essentially the same thing. So what an inversion of control container does, what this thing is, it's like a dictionary of. First of all, it's a dictionary of types with instructions, actions on how to build those types. So that's what these register statements are doing here. So in our constructor for our view model locator, we first of all set we say, okay, we're using simple IOC. The way this is done, you can actually throw this simple IOC out and use another one. There's a very good one that Patterns and Practices use and that we used on Windows Mobile called Func, which is a much more complex IOC container, but simple IOC is fine for most things. And I'm going to come back to that one in a minute. But all these register statements here, all they are doing is registering all the types in our application. So we're registering each of our summary. There's our summary view model, our car details view model, and our fill-up page view model. Inside there, you would put the construction instructions, but if it's just new it up, you don't have to put anything. So what it's saying is, okay, if I want a summary view model, just new one of these guys up. Now, this is where the services come in. Here's our iNavigation service. So this is registering the type iNavigation service, and what it's saying is, okay, when you want an iNavigation service, what you actually will do is new up a concrete navigation service. A navigation service, of course, implements iNavigation service, so that works. Likewise, the dialog service. And here's this bit up here is interesting because what we're actually got here is two variants of an iData service that we're using in this application. This is the runtime one, which is the real concrete data service, which actually connects to our real model and gets our real data out. But this one, design data service, is the one that is giving our design time data. So that's actually up here in our design. Here's our design data service. So this is just some dummy values that are going to be shown when we're in the designer. So not much in there. Implements our data service, of course. So there's a variant of this. And the other important thing about this, of course, is that we have some public properties on here. Main returns the summary view model. Car details returns the car details view model. And this, when we do that, service locator.current get instance, this is where it goes and looks up in its list of registered types and figures out how to build a car details view model, which is simply here, which is just new it up. But the other hidden bit of magic in here is that it goes, this IOC container looks at our car details view model, find out what constructors it supports, and if you remember, car details view model, here's our constructor up here. Here we go. Car details here, so let's just bring that down. So it actually looks at what constructor is available. There is only one for this. And the IOC container says, oh, OK, to build I need to new up a car details view model, but I also need to inject an iData service, an iNavigation service, and an iDialog service. So it looks up in its list of types, resolves them, figures out how to build them, and then injects them. So that's its job. And the other important thing to realize about this is this is only at runtime. So this enables the thing to work at runtime. We don't need this when we come to unit testing. You could use an IOC container when you're actually unit testing, but that's an unnecessary complication because at test time, we can new up one of these guys and plug in our own dummy mock versions of these classes, these objects that implement these interfaces. So that's kind of tough. I hope you stay with me there. But all you need to remember is that IOC, it means that no view model ever news anything up. They're always injected. That's the key thing to hang on to this. And these frameworks, they kind of help all this stuff, this magic to happen. So that was the demo on that. OK, finally, we get to the whole point of this. Unit testing Windows Phone XAML applications using the Silverlight Windows Phone unit testing framework. This framework was written by Jeff Wilcox on the phone team, and he did it first for big Silverlight, and then he ported it to run on the phone. So this is the one that I use. This other NUnit is available as well, but so this is the one I'm going to show you here. So all Jeff Wilcox's good work. Works just the same if you've done unit testing with other technologies in Visual Studio. Uses all the standard attributes, so we mark our test classes up with test class and our test methods. We can put tags on it, so allows us to run a subset of tests. Expected exception attributes and that sort of thing. But basically the whole point is in our test methods, you kind of execute the method that you want to test and then do a couple of these asserts. You just test the outcome to see whether the expected outcome has occurred, and it will throw an assertion if it hasn't. So that's the kind of bare bones of unit tests. And here's an example of a unit test. Here's our car details view model. As you can see, well, this variant on it actually only takes a data service and a navigation service, so we can do our own custom versions of them, new it up, plug in our mocks, set a few properties, call the method that we actually that we're actually testing in this method, and then a couple of asserts afterwards to check that what we expected to happen has actually happened. And if the asserts don't fire, then it's passed the test. So that's the essence of a unit test. So let's go ahead and implement some unit tests for this MVVM thing. So I'm going to add a new project to the solution. And you just add a standard Windows Phone application, TechEd tests. Oh, there we go. Interesting. Add that to our solution. Yeah, 7.1. And it's just a dummy single-page app. But then what we're going to do now is I'm going to go into NuGet and add in the Silverlight unit testing stuff. So if you want to find this yourself, these are recent ones that I've been using, but you can go online and best way is actually search for Jeff Wilcox. And if we've got a network, it should, yeah. And there's all his stuff. He does a load of good stuff. In there, it would be further down is the Silverlight unit test framework. This is it. So I'm just going to install that into my solution. Because I'm using MVVM Lite, I actually do need the binaries in my test project as well. So we add those in. So now we've added the required references into our test project. There is a README here, which you need to observe. It says, handle the loaded event in main page and add the following line, this.start test runner. Okay, so we'll do that. Just build it first so it picks up those references. Then in our main page, as it says, we need to handle the loaded event. So let's do that. Dot loaded plus equals. And then we go in here, and as it said, we need to actually do this.start test runner. So that starts the Silverlight test framework running. We can run this and see what it does by default. Debug, start new instance. So install the application. This is the standard UI for the Silverlight test framework. It counts down to 5, gives you a chance to actually select a subset. You can select one of those tags if you put tags attributes in. By default, we've got an assertion failed here. So this is the true experience you'll get when your test fails. Because of clearly we haven't actually written any tests yet. So it's we've got an assertion failed. Exception was handled there. So there we go. And as you see in the standard UI, it shows red. We can drill in to the test, and you get all this nice information. It's pretty nice, actually. It tells you how long it took to run, and actually the exception that it fired out, so you get all that information. So that's pretty cool. Now then, let's put a real test in there. So let's do a nice simple one. One of the kind of simple tests, like I said, you can have loads of tests. Some of them will be simple, some of them will be more complicated. One thing of the version of this app is that the logic to validate whether an object is valid or not is built into the actual model class. So we can kind of we could test the fill up, for example. So we can create a one thing I've forgotten to do, of course, is add a reference to what we're testing. So add reference to the actual test project. So that's a bit weird. I'm in the wrong place, that's why. Okay, that one I'm going to come to, which is a complete one. So this is TechEd tests. Add a reference to the test target, which is Fuel Tracker MVVM. So then we can say new up a fill up object, which is we need to resolve the namespace on that using Fuel Tracker.model. So then we can set some properties on it. Fill up dot let's say the price per fuel unit, set that to a negative, is equal to minus $3.50. So then we can say what we would expect, the thing we're going to test here, is that there's a property on a fill-up object called has errors. So we can assert that dot is true, for example, that fill-up dot has errors is what we're testing. Should be error. So you can put a little string on that. So now we can run that test, and that should pass, we would think. Let's just hit the run everything. Yeah, and we're green, so good to ship then, eh? Yeah, good. It's a pretty exhaustive test suite. But there you go. So that's that one. Now, in the actual sample code, of course, just remove that one. get rid of that one. The real one is this guy. So we've got rather more tests in this. Let's run that one instead. Run everything. So there's a whole bunch of tests in there. Code looks good. So we're all passed. Like I said, you can drill in and you can see everything is good. And fill up unit tests. So it's not an exhaustive test suite, but you can see there that we've got a bunch of tests. We'll run them all. And this is the kind of process that you're going to go through. Okay. So that's it, really. That's my step-by-step guide to actually re-architecting from a code-behind model to getting to a well-structured MVVM model with the added benefit of making it testable. But like I said at the beginning, if you don't bother writing any tests, but you get to the MVVM model, you're going to get a huge number of benefits from that anyway. So yeah, the 4 steps to use data binding is to just make sure that this is all about making sure that the presentation layer is disconnected from your logic. So we're publishing our data. We're using commanding to handle user interactions through kind of properties in the view model to actually execute the event handler kind of logic. We've externalized things like our dialog service and our navigation service and our data service to external service classes that are nicely just responsible for that bit of the functionality. And having done that, using one of these dependency injection containers and mocking allows us to write effective unit tests against our logic and keep those services out of the equation. Sometimes you will want to test, obviously, how your view model interacts with the service. That's completely valid as well. So you're not always going to mock them out of the picture, but it allows you to focus your test on what you're actually testing. A bit further references for you. I didn't go too deep into unit testing. There's kind of a little bit more, obviously, a lot more you can do with it. That was a simple example. There's a very good cheat sheet that was written by another fellow MVP with some good tips on kind of more like trapping particular exceptions and how to test private methods and this kind of stuff. So that's a good reference. Now, the second one on there, the 2 Microsoft patterns and practices ones, one of them was a bit of a surprise for me. So, first of all, the green one, they're building testable Windows Phone apps, is a load of good advice, basically talking about all the same stuff that I've been talking about in this session. The orange one, it turns out, I found out, after I had carefully crafted my fuel tracker version of the sample that's that is the tutorial app, and I'd carefully recrafted it using MVVM under MVVM Lite. I then happened to come across this reference where the Patterns and Practices group have done exactly the same thing. But they have done it with a different framework, so you can compare and contrast, and you can look, and they've used some Prism bits as their IOC container. They've used they use the Func IOC container in there. So there's a couple of differences in their approach. So two ways of doing the same thing. So, and I'm pleased to say there's a lot of commonality with what I came up with what they did. Somebody, no doubt, will ask about build servers and that sort of thing. So what I showed you there obviously has this built-in UI. The Silverlight unit testing framework looks to be it's obviously developer-centric. It's very, instant run the test, see what the results are like. But there is on Codeplex an effort to take the Silverlight unit testing framework and allow those tests all to be run on a build server. So you can use continuous integration testing using these same unit tests. So have a look at that. I said I was going to give you a list of MVVM frameworks. Like I said, I use MVVM Lite, but I'm not saying that's necessarily the best or anything. It works for me. These are a list of 6 that seem to be popular. There's probably more than that. So there's various different ways of handling this. But all of these frameworks are similar in the sense that they might offer project templates and they'll offer utility classes and they'll do versions of relay command and that kind of stuff. So you can have a look at all of them and find out which one you like. This couple of other, this is late in the conference, but you might want to go on channel 9 and have a look at a couple of other sessions that I can recommend. One from the phone track, and the real-world developer testing was all about unit testing can be hard and sort of what you want to do about that. I will be at the phone booth in the exhibition hall straight after this. So if you want to come and chat to me, please find me there. This is the end. So these were all the phone sessions. So you can catch these on Channel 9 if you wish to catch up on any of the other ones, including the What's New, What's in Windows Phone 8, and a bunch of other great stuff, and the standard resources. Now, the other thing about is the evals. Very important to us, so please submit your evals online. I've also been asked to say that, notwithstanding the network problems at the beginning of the conference, even if you had managed to get a network, the phone sessions on the early part of the conference weren't available. So please go on to there, and if you can, submit evals for the sessions you went to over the last few days as well. And of course mine. Please do that. It's important to us that we know what you thought of this. And with that, we have got a few minutes. If anybody's got any questions, I'll be very happy to take them. Anything? Yeah. Is there any performance issues with using the frameworks? That's a really good question. So, and there's kind of a story behind the answer to this, in that, did you ever do any compact framework dev on Windows Mobile? Okay. Yeah, well, Patterns and Practices have done some great stuff, but not perhaps their greatest hour was the mobile software factory, which was some years ago, where they basically ported a load of stuff that they had running for desktop Windows Forms app development, and they ported it down to Windows Mobile, because you can, because the compact framework had sufficient support and that sort of thing. But that particular framework was very reflection heavy, and basically it was a great way of creating extremely slow running applications, was to use that particular framework. Everybody's learnt the lessons of that, so these ones are very lightweight, and that is obviously crucially important when you're running on low-power CPUs, battery-powered. So the dependence injection, this kind of looking up in a tape, it's just a dictionary of type and then action. So the lookup's very fast to resolve an object. The logic in the IOC to actually new up an object has been shown to be very, very fast. So I think the benefits far outweigh the very, very minuscule overhead you've got compared to newing up objects directly. Yeah. Any more? Yeah. Any mocking frameworks? Yeah. Okay, so the question was, are there any mocking frameworks that we can use with Silverlight for Windows Phone to help with the creation of mocks? So mocking frameworks are a set of tools that allow you to generate mocks easily. No, I'm afraid the answer is not that I'm aware of, so nothing to help us particularly in that respect. Okay, good. Well, that's great. Thank you very much for your attention. I hope that was enjoyable for you, and I hope you enjoyed the conference. So thank you very much.